This is a What the Physics video. In the original recording, we were not clever enough to include learning targets, because how can you possibly hope to learn without a learning target? Here it is, learning targets about vectors. I can add vectors graphically using tip to tail and determine the max and min values. Ooh, that sounds awesome. And I can add vectors analytically using trig functions, including breaking vectors down into components. Sounds delicious. I know. Let's do this.
So here we have a What the Physics video. This one is about vectors. So this is very exciting because we are using the smartboard. Woohoo! Yes, smartboard. Lovely. We have a game.
Yes, ironically, this is a video about us using a smartboard. Let's go with it.
Lovely. So to demonstrate the awesomeness of the smartboard, click. We have a game. Games make physics fun. I need a volunteer, please, to demonstrate how fun this is. Thank you, dear. Come on up, please. As you can see,
and to avoid using people's names, I tend to refer to them as dear or buddy or whatever, because, you know, we don't have permission to use everyone's names. Let's go ahead and speed this part up.
We have some type of sorting activity here, where the left column is vector and the right column is scalar. Well, scalar really, but it's fun. It's even more fun to say scalar, right? And that's what we want. We want fun. So what you need to do, please, dear, is you need to see what's in your list at the bottom and drag them up into the correct category. And you can certainly do it by yourself if you want, or you can get assistance from others. Okay? So go to it. Keep going, folks. Others. The acceleration is a vector, okay?
We'll skip ahead a little bit.
Volume is a... What do we think of this? So, according to this, and we'll okay, I guess you can sit down for a moment. Velocity, acceleration, force, and displacement are in the vector category. In the scalar category, speed, time, volume, mass, distance, and temperature. Okay, so let's go ahead and check. Check. Yay! Oh, we're having fun. All right, so make sure that you filled in your list or drawn your arrows or something. This is the best class ever, Claire. One person in the room has to stand up. Let's move on. That was just a review of what we've already learned with vectors and scalars. Now, here's the graphical method of adding vectors. Guess what? I'm going to need another volunteer. Oh! No, really. You need a volunteer, please. Oh! It's going to hurt my voice if I keep doing that. If you'd like to choose someone, yes, since you went first.
No.
Okay, that's the way it works. Sorry, but you get to choose next, okay?
I can help it, right?
Sure. You guys are all afraid of things. What has happened to you if you've gotten something wrong before in this class?
You got it.
All right, so you got punched? Okay. For clarification purposes, no, that didn't happen. Okay. So starting from the X, and we can see what a big old X is, add the vectors. And which star are you going to end up at? So notice in red it says, must add vectors tip to tail. So if I take this guy here, you can see that over, well, how can I point? For recording purposes, let me go back over here. This guy right here is the tip, and this is the tail, yes? Okay? I heard 2 people respond yes. Let's discuss that again. So this is the tip, and this is the so this is the and now it's the and this is the and now it's the and now it's the and here is the and this is the middle. Okay, good. Okay, so when we add tip to tail, what we need to do is move these around. So like here's the tip, and then we put in the tail, right? So from tip here to tail there, right? But I'm not gonna lead you astray. I'm not sure where you should start, which one you should start with. But you should choose one of these and start right there, and then we're gonna end up on a star if you did it right. Go ahead, sir. No pressure at all.
Go on top.
This one.
Yeah.
Okay.
Connect to the solar.
So the tail is at the tail. We're starting at the X. So the tail. You use that one. That's fine. The tail of that guy.
Use the one below it. And yeah.
The tail of the vector needs to be at the center of the X.
The one below it. The one in the middle. That's more. Yeah, that one.
This one, right?
Yeah.
Okay, so that one's tail is at the center of the X, right? Okay, so which one are you going to use next?
That one below it. Straight. No. Okay. No.
This one.
Yeah.
Right here. No. You're adding these tip to tail. No.
I don't know.
They're not locked in position.
Okay, settle down, guys. Get him. Okay.
This one goes to the tip, and then
So put that on the tip with the other one. There we go. Lovely. Okay. Hey, oh, wait. Stop the violence. Okay. So let's keep adding tip to tail, yes?
add another tip. So
All right.
tail to tip. Pick one. Mighty Mo.
You're a helpful dear. Thank you so much. Okay. And then, okay, unfortunately you have to use all of them.
No, don't do that.
You can if you want, it's just hard to see.
Take the small one. Put that one going.
No, get that. Where did that one go? Wait, which one? The one that's on the next one? Here it is.
Yeah.
No, the one that's attached. The one that's on the line. Yeah, here's that. Get the one pointing up, straight up. Yeah, that's okay.
Okay, and
That's
then,
slanted to the right. Yeah. Get the one that goes straight down.
okay.
Pass it down now.
Yay, applause. Okay, now, you were all saying, oh no, you did it wrong, right? You did it wrong. Really? Well, let's see. Take that out. Well, this is giving me no love to. Put this one in its place. This is, we have to realize this thing. There, that works as well, right? So, oh, fair, you did that one wrong too, right? Okay, well, let's see. I'm going to put this one here, and this one here, and that one there. And I could have done it actually any order, and it would have worked. So written down here in blue, it says, how can we add these vectors without knowing the order? Well, order don't matter. The order in which we add the vectors does not matter. Oops. Yes. Okay, so that was adding vectors. When we add vectors, we add them tip to tail. When we subtract vectors, how are we going to do this? We cannot do tip to tip. We cannot do tail to tail. Vectors are designed to be added tip to tail. Okay? That's how they always have to be added. That's how we'd have to subtract them too, except for subtraction purposes, what are we going to do? Well, if we take a look at this and see 5 minus 3 equals 2, then we'll go. I can also look at this sentence and say 5 plus negative 3 equals 2, right? Is that a true statement? So what we're going to hopefully see is subtraction is really just the same thing as adding the negative or adding the opposite, right? So I'm still going to add vectors tip to tail, but what I'm going to see is in order to subtract them, I just need to flip around the vector, and then I will add. Okay? Hopefully that just made sense. Okay? So if I wanted to say 5 minus 3, I'd have to add on 5 plus negative 3. Okay? All right, well, we'll try it out. So let's say we're flying. Okay? And if we're flying, we have a particular speed, and here's a lovely airplane picture. And we have the engine's velocity pushing us forward, yes? Okay. Well, who's ever been flying before? Okay, who has ever heard of the pilot saying like, oh, well, it should take this long to get there. And then later on, the pilot says, oh, you know what, folks, there's some good conditions. We're able to get there a lot faster. Why do you think that is? Winds, right, okay. It's the winds are pushing us along. Or the winds might be throwing us off, right? They might be pushing us to the side, who knows what. Okay, so let's take those guys into account. So, flying with a tailwind will increase your plane's overall velocity. So when we say a tailwind, we just imagine winds hitting our tail, right? It's pushing us along, yes? Okay, so we're just going to add the vectors together. What would it be if it were a headwind, do you think? Oh, headwind, oh, that's the bird from Harry Potter, right? Headwind. It's been too long. You guys don't know who Harry Potter is? I'm sorry, do I have to reference? Is Percy Jackson more recent? I don't know. It was Percy Jackson. Okay, forget it. I'm literally just not working out here. Okay.
Decreases the velocity.
Yeah, I grew up with Judy Blume was the common author. But okay. So yeah, it would be slowing us down, kind of like the mood that is going on right now. So let's go ahead and get another volunteer. Hey, volunteers! If no one volunteers, then yes. Volunteer! Woohoo! Looks like you get to choose, sir.
All right.
The benefit of quote volunteering. Oh, who doesn't? Yes. Make people into victims. That's nice. That's the benefit of smartboard. Okay. No names, please. No names.
No names. How about you?
Okay, thank you, volunteer. So it says use the long vector to show the plane's engine velocity and the short vector to show the wind's velocity. So what we're going to do is have, it says an airplane flying with a tailwind. So this guy right here, this is the engine's velocity. So what you need to do is figure out which one would represent the tailwind and add it on tip to tip. So which way is the tailwind going to be going? That's what we said earlier. Flying with the tailwind will increase the plane's... Oh, hey, what's going on there? No, don't unlock.
What? Okay.
What have you done? You've destroyed physics. Yay, thank you very much.
Get it out.
I wanted to lock it. I couldn't figure out how to lock it. Thank you. All right, yes. All right, so it's locked. Good. Okay, all right, so put that back up here. Grab us this again. Here, we'll give you some more space there, too. All right, so the tailwind, what did we say over here? Thank you for your help, by the way, dear. The tailwind would increase the plane's velocity, right? So what do you think the direction should be? Let the record show people are pointing to the right. That is the engine's velocity.
Wait, what?
They all go in. They all go in.
Oh.
No, but you added.
Okay. All right, stop. No. All right, that is the guys, it did say the long one is the plane's velocity. Okay, so this one will be down here. So there's 3 different scenarios. Okay, you are using one of these. Yay! Okay, good. For an airplane flying with a headwind. Oh, yeah. Headwind. It's not a funny joke, apparently. Just click off to the side. Tip to tail, right? Tip to tail, not tip to tip.
No.
When we said no earlier, we meant it.
Just put the tail on the tip. There you go.
Over just a tad. Hey, there we are. Okay, and then an airplane flying with wind blowing perpendicular to its... Yay, look at that. That was a smooth one. Well done, sir. Yay. So what are the resultants going to be? Well, the resultant guy here goes from the tail of the first to the tip of the last, yes? Okay. The resultant here goes from the tail of the first to the tip, out there, to the tip of the last. And the resultant here goes like, oh, that's a terrible straight line there. Okay. All right, so notice how are those are comparing. When we're adding the vectors, of course, the resultant is getting nice and big. Subtracting them is getting smaller and such. Okay, hint for subtracting vectors. Okay, what we're supposed to be seeing here is the whole subtraction is really just adding the negative. So if I said actual numbers, let's say the engine velocity were 500 meters per second. Okay, that's really fast. That's preposterously fast. That's faster than the speed of sound. So let's say 100 meters per second. The wind velocity is 20 meters per second. Okay, if I say 100 plus 20, that's my first scenario that was drawn. That was this guy right up here. If I say, so that would be like saying 100 plus 20. This one would be like saying 100 minus 20, but because we cannot simply go tail to tail, what we're really saying is 100 plus negative 20. Okay, how did I do this one, or how would I do this guy here? Well, they're not exactly on the same axis, are they? But what does this kind of look like now? Triangle, specifically a right triangle. So we'll be talking about the Pythagorean theorem. Right. Good, good, good. Okay, so adding several vectors. Oh, look, another volunteer. Use the provided vector arrows to add the vectors in the order and combinations listed. See how they compare. For clarification purposes, the short arrow is 2, the medium is 4, the long is 5. So, volunteer, please. Are you volunteering? Okay. Are you volunteering just so you can pick someone later?
No.
Okay.
Come on now.
Okay, so 1A.
Doesn't matter which way.
So we usually say to the right. There we are. 2 meters east and then 4 meters east. Okay, so drawing the resultant. Go ahead and use red for the resultant. Let's go from the tail of the first to the tip of the left. Okay, so what is that resultant going to be, by the way? 6
meters.
East, right, okay, 6 meters east. So go ahead, oh, I'm sorry, hold on just a second. Go ahead and we'll write in 6 meters east, okay? Let's throw E. Well, okay, now go 5 meters west. Okay, from the tail of the first. Okay, good. So what is the resultant there going to be? 1 meter east, excellent, okay? 1B, 2 meters east, 4 meters east, and 5 meters west. Okay, why do you say everyone's like, oh, it's the same thing? Not exactly. I mean, the answer is the same thing, absolutely. But the commands were not exactly the same, right? What did I do for 1A? When I added the first two together, what did I have to do? I combined those first, and then I added on. What do you do? I look away for a moment, and you're like, whoa! But at least we're still recording, so that's, there we are. Okay. I'm telling you, the 3 people that are going to watch this video are going to be really, anyhow. In part A, we combined something and added it on, right? In part B, we just added them all individually. Okay, so what is our, oh, all right, sure, move it over, that's fine. Okay, much easier to the result. So going from the tail of the first to the tip of the last. This is in 2 dimensions, though. Here, now let's see. There we go. Okay. Starting here. There, that's what I was going for, right? Okay. They say, oh, fair, I don't know what that length is going to be. Well, okay. We'll come back to it. How about B? Okay? You might say, oh, that's a little bit easier to see, right? In case it's not super clear to people. Okay? This was the 2 meters east part, right? So from here to here, what's that distance going to be? 3 meters, right? Okay. So 3 meters. What's this guy going to be here? 4 meters north, right? Okay, remember we had mentioned about triangles earlier. We could do Pythagorean theorem. We could also recognize it's a Pythagorean triple. I don't know what that is. It's a special triangle, I think is what they call it. We'll go ahead and do the Pythagorean theorem, if you like. What's that? 5. Yeah, it's a 3, 4, 5 triangle, right? So this is 5 meters. You say, well, great, fair, but I don't know what the value of that upper one is. Well, what's this guy up here going to be? It's the same thing. So, it's 5 meters, but how are we supposed to know? Well, I can change up the order in which I add these things, and that won't matter. So, what did we learn here? Just like adding regular numbers, add vectors in different orders, and you can group them as well. So to summarize, order don't matter, and combinations don't matter. Thank you, volunteer, by the way.